We left off last class. We had gotten through pretty much ranges and using loops. And we showed you how to use range, right, to generate a loop. To generate a loop that actually references specific elements of a list using a for loop. What you do is you generate something that looks an awful lot like a list using the range call, right? List of range of 10 generates something that has the indices from 0 up to 9, right? Starts at 0, goes to 1 less than whatever value you put in here. This call will generate something that goes from 0 to the length of the list minus 1, which is exactly the indices of the list. The for loop successively sets the loop variable I to each one of these values in turn. So I is 0 the first time through. We reference name sub I. Second, right, we can pull it out of the list, capitalize it, and put it back in the list, most importantly. Second time through, it equals 1, and so on, all the way up till it gets to, for example, 9. So we can do like a capitalized list, cat, dog, horse, pony. And we found out that when we do this, and we make this actually a list as opposed to 4 separate parameters, right, our capitalized list gets changed so that, dang it. Having just passed that in as a parameter, I lost all access to it. So we can do something like, or n equal there we go. Off to a rough start. You can see that we capitalized everything, right? So that's exactly what we were talking about being able to do, and we kind of worked through all that. That was the refresher part. What we want to start doing is we want to look a little bit more closely at the operations that are allowed by the range call. So range allows us to generate sequences, right? So we can do list, range, 10, 15 by 3, right? And that'll start at 10, go until just before 15. It won't generate 15, but it would generate 14. And right, so it starts at 10. It adds 3 every time. It generates the sequence 10. 13, when it generates 16, 16 is greater than or equal to 15, so it stops. It doesn't generate that one. If we were to do this by 10 to 20 by 5, what we'll generate is we'll generate 10, 15, and then we'll stop, because when we generate 20, we don't actually get to the last one. We stop on this side of the last one. So we can see that we can walk through and we can generate indices that can be used to access values in a list. If we had a list of more than 15 or 15 or 16 or more things, we could generate all of the indices we wanted within that range using some combination of starting point, ending point, and increment. as long as we have a pattern. So the question is, if we're essentially generating indices, is there a way to pull out indices from a list, other than walking through sequentially one at a time? So in other words, instead of just going n, right, and n sub 0, n sub 1, can we actually pull out, for example, cat and horse, or cat and pony, or dog and pony, or dog, horse, pony? Can we actually apply other operations, akin to a range, that would give us those indices? And, you can see doing a range, for example, if we have the length of that list is 4, right, we could say if we wanted to generate all the indices, we could do range length of n, right, and that will generate the numbers from 0 through 3 once we put it into a list, right? That'll generate a list of 0 through 3, which are the exact indices we need to access cat, dog, horse, and pony. If we wanted just cat and horse, we could do the same thing, giving it a starting point, let's say 0, an ending point, the length of the list, and an increment, right? 2 will skip every other. Let me put that in correctly. Has to be the inputs to the list call. So 0 is the index of cat. 2 is the index of horse. So we can pull out the indices for cat and horse. If we wanted to do dog and pony instead, we could change our starting index to 1. Now we generate 1, the index of dog, the index of pony. If we want cat and pony, right, we could do 0 and skip by 3, right? So there are ways to generate the indices that pull out various portions of the list, or generate the indices for specific portions of the list. There's a concept called slicing, and slicing allows us to do this on the list itself. And it has a format very close to what we're actually seeing with range. So let's start out with our CO2 levels instead of our dog, horse, pony, right? And I can pop this in here. And you son of a gun. The one thing about Spider is it doesn't like when you change monitors, and I pulled something down below my monitor break. And it is giving me all sorts of a headache now. Okay, we're back finally. Of course, it didn't do what I wanted it to do either. So. There we go. All right, so this is kind of a pain in the neck right now for some reason. Okay, so we have CO2 levels. Thank you. About time. All right. Maybe what I need to do is pull this other one down. Okay. So we have CO2 levels. And let's say we want to pull out just 3 values starting at, oh, I don't know, 0, 1, 2 through 5. 2, 3, 4, and skip 5. So we want to generate indices 2, 3, and 4. If we want to do that, we would use a range call, right? We could generate the indices themselves using a range call. List range started at 2, go up until 5, and we want a skip of 1. We want to generate every index in that range. And if we do that, we generate indices 2, 3, and 4. So we could generate a loop that would walk over those 3 values using a range call. Well, it turns out we can do something similar using a concept called slicing. So if we want to just pull those values out into a sublist, and we just want to create a new list with those values, we can use the same kind of notation within our square list brackets. Now notice what we've done is we've replaced this range call, and in fact this range call has been replaced with a square bracket, right? The commas have been replaced with colons, but the numbers remain the same, and now we generate a new list that has just those components corresponding to the 2, the 5, the 2, the 3, and the 4 items in CO2 levels. So let's see, 2, 3, and 4. So 328.07, 328.07, 333.91, 333.91, 341.47. So the slicing, what slicing allows us to do is it allows us to pull a value from a list, or pull a value or values from a list that have indices corresponding to the pattern we generate. Okay, and it comes, again, the 2 is the starting value. The colon separates the starting value from the ending value. And then after that, we have the increment. All of those are actually optional. So we could do something like CO2 levels, colon 5, 1. That'll start at 0 and generate from 0, 1, 2, 3, and 4. We can have colon, colon 1, right? And that'll generate starting at 0, ending at the length of the list, incrementing by 1. That'll give us a copy of the entire list. We can do by 2. That'll take every other element. We can give an arbitrary stopping point of element 4. That'll take out the 0 and 3 elements. Or we could do, put a 1 here, and that'll skip the first element. So we have some options here. This will start at the odd element, and the odd elements take out index 1 and index 3. This takes out index 2, 0, index 2, and then it won't generate index 4. It stops 1 before the middle value. All right, so yeah, so that's kind of what this whole slicing thing is. Let's take a few more examples with our animal list. L1 is cat, dog, hawk, tiger, parrot. Okay, so L1, 1 minus 1. That's kind of interesting, right? We have a minus value there. Well, if we remember, right, this is 0 and minus the length of the list. So for this list, it would be 0 and minus 5, 1 and minus 4, 2 and minus 3, 3 and minus 2, 4 and minus 1. So we can refer to those elements. L1 sub 4 is parrot. L4 sub minus 1 is parrot. All right? So when we walk from 1 up to minus 1, what we're doing is we're going, well, we discard 0. Dog is 1. Hawk is 2. Tiger is 3. -1 is the same as 4, so we stop before we get to parent. Okay? So anyway, negative indices are allowed. They're just converted to their associated positive values. And we can continue walking this down. You know, if we go -2, -3, -4. Okay? If we start at 0, we'll get the -4 one at cat. And then if we do -5, what do we get? Nothing. The good thing about lists is you can actually walk off, about slicing is you can actually walk off the edge of the end of a list using slicing, and what you will get is just what falls within that range. So if you walk off the end of the list, you just get the empty list, or it stops at the end of the list if it's just the second increment. All right, any questions on that? Is that kind of making some sense? Let me pull down here. Yeah, so there's a question on lecture exercises. You can't take late days on lecture exercises. We're dropping 5 of them, right? So you don't want to use a late day on it because they're not that valuable. The 17 that are left are worth less than 1 homework. So, you know, altogether combined, the 17 left make less than 1 homework. 5 lowest lecture exercises, not 6. And we don't offer late days because it doesn't make sense. You don't want to use a late day there. We don't offer excused absences because, quite honestly, we drop in 5. Right? You can miss any 5 you want. All right. So here's the general form of slicing. I've been kind of using that to get you used to it. Any of the 3 values is optional. To copy an entire list, right? If we have L1, to copy the entire list, we can say L2 equals L1, and just put a colon in there to let it know that you're accessing the entire list. L2 and L1 will be the same, but unlike L3 equals L1, we have actually made a copy. So L3, L2, and L3, L1, and L2 all have the same values. But if we do an L3 or an L1 dot append, let's put a crow in there in honor of Halloween. L1 has a crow, L3 has a crow, but L2, generated with the slicing operation, is a separate new list. It's one of the ways to do. Yeah, it's one of the ways to do the copy operation. Okay, and if number 10, if on the lecture exercise is in with 2 late days instead of 0, I will take that off. You guys again don't want to be using late days on your lecture exercises. Much more valuable in homeworks. Well, there we are. Sorry, getting lost. Okay. We talked about using negative increments to generate a reversed list. You can use positive and negative indices in the list. We saw that with our little negative indices here. That just gets converted into the equivalent positive, and then it does the operation as if it were the positive number. But it turns out we can also do negative indices. So if we have L1, right, and L1 is now has a crow at the end. If we do L1 colon minus 1, what that's going to do is it's going to start at the far end of the list and walk back in reverse order. It almost works like a for loop, but what it's really doing is it generates a new list. If you were accumulating a new list in a for loop, it would work exactly like the for loop based on the indices. So yeah, you could make an equivalent for loop. So there, that walks through backwards. So crow, parrot, tiger, hawk, dog, cat, and you can put indices in there as well as long as they make sense. 4 and 2 maybe. If they don't make sense, 2 and 4, well, that'll give you an empty list. Okay, so you can walk backwards through the list or through any part of the list using an increment, and you can actually even change the increment if we want to skip things going in backwards order as well. And it does make it really easy to check for palindromes. Yes. All right. What else do we have here? Lists also have concatenation and replication. So if we have L1, we have L2, and we have, what do I have, X? Nope. We had L1 and something else. Well, it doesn't matter. Oh, N. There we go. We can do L1 1 plus N, and that generates a new list that has all the elements from L1. Those are the non-capitalized values, followed by all the elements from N. Right? It doesn't modify either of L1 or N, but it does generate a new list, and that new list can be assigned to, let's say, L4. Okay? And it also works on replication. So if you want to do something like you want to make a list that has all zeros, maybe you're doing a starting grid for Pokemon, you can have a list whose members 0, multiply that by 10, and now you have a list with 10 zeros in it. Okay? Okay, what else do we have here? I'm going to really quickly hit this because I want to get on to the next lecture. There are two operations you have to be aware of. You know that if we have a string, we can convert a string, if it makes sense, to an integer, right? So if we have num equals, and this is one of the things you're doing in your homework, right? We can do an int num to convert it to an integer, or float num to convert it to a float. If we do, so we also have this list operator, and we can also do list on something to convert it to a list. Except it's not going to work the way you think. If we take a string S that says hello world and we do list S, it takes out every character in the string and makes it an element in the list. And in general, that's not what we actually want to do. And you should be seeing some of this in your homework 3, where we told you how to split a list. Okay, if you actually want hello and a list whose members are hello and world, then you can do something like an s.split. And that'll generate a list, and the list has hello and world in it. And you can also do a s.split with a space, and that'll also split it to space, and it will give you hello world. They are not the same operation, though. So let's take something else. Let's do S, and we'll give it, I don't know, a couple spaces in there, maybe a space at the end, maybe a space here. Maybe we'll throw in a /t, maybe a /n in here. Okay, that's a new S. It's not exactly equal to the old S, and we can print this out, right? And we get some funky values. And if we do s.split now, with no arguments, what it's going to do is it's going to split that at any white space. and it's going to give us our good old hello world back again. If, however, we do this and we explicitly put in our character space, it's only going to split. It's going to split only at the space. It doesn't remove /t. It also won't remove /r's if you guys are getting /r's at the end of your lists of words. Won't remove /t's. Won't remove /r's. And places where you have a space in the leading or trailing places in your list, or where you have multiple spaces, what it's going to end up doing is it's going to end up giving you a series of empty lists within your list. Okay? To understand this, we have to go back and understand how to build up a string from a list. So let's go back to, I don't want to mess up with my S, so I'm going to say V equals, or H equals hello world, so I can remember it. Right, and we can do something like T equals list H, right, and that gives us, you know, all the letters, and now we can do something like S1 equals string T. Did I mess up? No. Oh, that's going to suck. All right, we're losing some of our old stuff. Okay, so we're back where we started from. We can do S1 equals string T. And now if we look at S1, what we find out is that it's now a list with, instead of, I'm sorry, it's a string of the list. So it is this string here. So that's not exactly what we want to do when we're splitting, neither the split operator or neither the list operation applied to strings, right? This T equals list S, or the string operation applied to lists actually give us what we want, right? This is just a string that's now enclosed in a string, the string evaluation of a list that's now enclosed in or contained in variable S1. So that doesn't help us either. So we looked at this operation split, and I threw in some things here. I threw in a couple spaces there and a couple spaces here. Okay, so we looked at the s.split, and we found out that s.split returns a list, discarding all of the white space and breaking it up at the first white space it hits, right? So we get hello and world nicely. If we actually want to split on the space, we get something that looks like this, where we're maintaining some empty sets, and we're maintaining some we're maintaining the /n and the /t. We'll set this to X. And we'll do Y equals just the regular split. And now we're going to get into how to reconstitute lists X and Y into a string, and that comes with the join function. Now the interesting thing about the join function is you don't call it, you don't do like x.join. Instead, you tell it what separator, right? If we have this list, let's say Y, and we want to reconstitute y into a single string, we don't do y.join. We pick what we want to be in the middle there. So for example, if we do a space dot join y, what we get back is hello world with a single space in the middle, right? So we started out with S, we removed all of the white space, and now we've put back just a single space where there was multiple white space before, and we can put whatever separator character we want there. We can do C, for example, hello C world. We can do multiple characters, right? And remember that y was generated as y calling split without the argument. Okay. X, on the other hand, is far more complicated because it has all of these other empty lists and /n's and /t's. And the reason for that is because if we now do our join, right, we originally split this on the space character, and if we do the join X, we actually reconstitute the exact list, the exact list we started from. So split without any arguments discards white space, but you can't reconstitute the original list from it. Split with an argument such as a white space, you can reconstitute it, but you end up with all of this garbage in your lists. If you're trying to process words, that's probably not what you want. Okay? All right, so anyway, that's kind of where I wanted to be. We talked about indexing. We can also talk about slicing strings. You can slice a string, but remember that you can't assign to a string. So you can't, right? So you can't say S27 equals something, right? All right, so that's all we're going to talk about on 10. We've got about 35 or 40 minutes on 11. I'm going to get into that right now.